Welcome. In this video I'm going to show you how you can perform a modified log likelihood goodness of fit test using Python and my stikpetP library. This video will actually focus on how to perform the test, not so much if you should be performing this test. There are quite some alternatives and this is just one of them. To show you how you can do this, I'll first need some example data, so I'll import pandas, and then I have a file called GSS, General Social Survey from 2012, which I slightly adjusted, so I'll load that one in as a data frame. I actually don't need all the data, I just need one nominal field, so once it's loaded I will actually select only the marital status, the MAR1 field. And just to have a quick look, I'll use value count so I can see the counts for each possible category. So for example, there were 181 people who indicated to be widowed. Now my library is available by downloading it straight from my GitHub. So don't just use pip install, but actually do the entire link. And once that's done, you can import it just as any other library. Now the function of interest is the TS modlog likelihood goodness of fit, so TS short for test, mod for modified, logarithm likelihood, and GOF short for goodness of fit. It only takes data as a compulsory input, and if you want you can specify the expected counts and even specify if you want to use a so-called continuity correction. I'll just use default settings and feed it that nominal field of the marital status, and we get one data frame as a return. It shows the sample size, the number of categories, the chi-square test statistic, the degrees of freedom, which is just the number of categories minus 1, the p-value, I'll get back to that one, the minimum expected count, the percentage of cells that had an expected count below 5, and a quick description of the test that was used. Mostly that p-value is of interest. If that is below a predefined threshold, usually 0.05, we would say there is a significant result, and that in this case in the population the categories probably won't be equally distributed. So if you want you can also specify the expected count. So for example I have these expected counts up front, so I'll simply put those into a separate data frame with those expected counts, and then I can actually use that in my function and say, well, the expected counts were these, and then we get a slightly different result, still being significant though. Alright, I hope this video was helpful, and thank you for watching.